Managing networks is a major part of BioDati Studio. Here we're going to demonstrate searching for networks. We can filter based on various facets associated with the networks, and we can also search for keywords inside the networks. Here we're going to search for apoptosis. Let's take a look at the nodes list and the associated metadata. We can also filter on any of the columns. We can export the network, and we can also visualize it. The labels will automatically show when you zoom in tight enough. One of my favorite techniques is the lasso selection, which allows you to lasso irregularly shaped regions of your network. Visualizer selections show up in your grid and vice versa. Here in the grid, you can see the edges selected, and that's based on the visualized selection. Moving on to creating networks. Here we're using Network Neighborhood, searching for a node in the edge store, and then from there we'll select a node using the completion service. Now we're going to search the neighborhood one step out from the urbane abundance of AKT1, and we find 12 edges. Bumping this up to 2 steps and resubmitting the search, we wind up with over 1,000 edges. Now we're going to select all of these and create the network. We fill in the information needed and then hit Create. We can also view the supporting nanopub for each edge by clicking the nanopub URL, and then we can see the nanopub for review. Now we move on to searching for nanopubs. Now we're going to search for a specific PubMed that has 8 nanopubs associated with it. You can see the evidence is blocked out in the abstract, and the additional evidences for the nanopubs in the evidences section. Looking at one of these nanopubs, we can review it, and potentially edit, delete it, or export it. Let's see if a particular relationship exists in the knowledge base between VAV1 and AKT2. We're going to create one from a PubMed that was found. This PubMed has an evidence statement in it that is going to be highlighted and added to the evidence for the nanopub. Moving on to creating the Bell assertion. We start creating the Bell assertion using the auto-completion and contextual help support. In this case, VAV1 decreases the RNA abundance of AKT2. We can also add annotations or experimental context. Going back and searching for AKT2 and VAV1, we can see our nanopub exists in our knowledge base now. We've barely touched on the functionality of BioDati Studio, but you can look at the link below for additional help documentation.